At Fuel Injector Clinic, we offer the highest quality performance injectors in the market, but also back it up with precise matching, great tuning data, excellent customer service, and a lifetime warranty, offering an incredible value to our customers. Fuel Injector Clinic uses the newest generation of Bosch base injectors for all of our high-impedance injector sets. We start with the best base injectors available and then optimize them for all performance applications, bringing great reliability and performance to all of our products. All of the injectors we offer are designed for use with both gasoline and E85 applications. Fuel Injector Clinic utilizes custom injector flow benches to offer the most comprehensive injector matching and tuning data in the industry, matching our injectors by both flow rate and individual offset value, going above and beyond the industry standard to optimize injector performance from idle all the way up to full throttle.
Hey guys, it's Joe, Justin, and Jens from Fuel Injector Clinic for Tuning Tuesday episode 22. Our primary focus today is going to be fuel injectors.
Fuel injectors, the little squirters in your engine that make it run and make horsepower.
The replacement for carburetors. So where do you guys want to start today? I know we just rolled the kind of like your guys' media video.
Yeah. I'd like to introduce our company, and that was very cool. We appreciate being here. It's always fun to be with our partners.
So how long have you been in the fuel injector business, Jens?
Fuel Injectors has been 11 years now. I've come up through the ranks of the motor racing industry. I'm originally from South Africa, started there with a good friend of mine who was a karter and so on. Ended up in Europe, in England, working with Jackie Stewart's team in F3 back then. Now that's the Red Bull Formula One team.
Okay.
And then life brought me over this way. Very gladly so, loving to live in Florida here with you guys, and eventually it brought me back to my roots of motor racing, and I got an opportunity to buy this business.
Yeah, I mean, we've been, I remember talking to you back in 2011 or 2012.
Right.
We've got some of your injectors in and have been using them in some of our own cars. And it seems like you're bringing a lot of technology to the table, a lot of options. And, that's cool. That's why we've got you here on the show today to learn more about that.
Yeah, we're, like to be a partner in the greater aftermarket, sharing information, gathering information, and making cars work for the consumer.
So you're saying making a lot of horsepower and doing it well?
Yeah. We're one little component of that.
Yeah.
That's the thing. We always tell people, we don't make power, but we're necessary to make power, and so we're one of the cogs in the machine.
Well, without you guys, all we have is just big air compressors. Without your guys' help, nothing goes bang. So.
Yeah, you had the bang to the suck and the
suck, squeeze, bang,
suck,
blow.
squeeze, bang, blow. Yeah, I've had to get that together there for a second.
So do you want to start with the basics of how a modern fuel injector works, or which direction you want to go with this?
Yeah, we can just get a little bit of background on fuel injectors, and maybe share a little bit. So many people think that there are electronic components and so forth in fuel injectors, but at the end of the day, it's an electromagnetic valve. Mm-hmm. Chris, if you can go to the injector picture there. There we go. Awesome. We can share that out there. So that's cut through the injector, and it's simply a valve that's opened up against the spring that holds the valve mechanically shut. Mm-hmm. And it's activated by sending the power to the coil that is around the valve and opens it up. Pretty simple, like lots of people. It's basically like your little door chime and works on your house. Now, the tricky part comes, you got to do it a million times, over and over, and you got to do it accurately and repeatedly. And with that comes the progression of the different evolutions of the injector. We were all fighting with injectors, in the late 1990s and so on, because they were clunky and heavy. Today, these new injectors that we use, which are basically a Bosch EV14 based injector, super light valves, accurate springs, machining, everything is awesome. And with that, we're able to control a big injector for, these tiny amounts of fuel that we need for idle and such.
And that's what you're starting to get into, what really matters to us as tuners. Joe, I've heard from people before, well, can't you just dial these injectors in? No, it doesn't work that way. This is a very carefully regulated and controlled valve.
Yeah.
And we're dialing your car in. We need accurate injector data. We don't need to be worrying about, whether your injectors are right or not.
That, and not only that, we need controllable injectors, because the data can be accurate, but that doesn't mean it's going to work on a specific application. If you're dealing with a very large minimum pulse width or a very lazy injector in terms of dead time, like you can to some degree calibrate that, but at the end of the day, when you have a very small window in which to get a very, very small amount of fuel into the engine,
Yeah.
it has to be very precise.
Because you want your 1,000 horsepower street car to still idle well.
And not idle at 11.5 to 1
Yeah.
or 80 lambda.
And I'm sure you've seen the evolution of the ECU and the number of tables that there are in fueling and all the other parts of it. If we go back to a 2000 ECU, there's just not that much data in there. And as the industry, as in the OEs, have realized, oh wait, every time we have a little bit more information, the car drives a little better. The
Emissions ends up going a little bit better.
And so today, you buying this car, it has all this necessary information that you need to get a successful tune that mimics what everybody's basically used to from a day-to-day driver.
We've got to populate every one of those tables with accurate data. And that's where, working with good injector companies comes in. If we're using factory injectors that are larger in your car, well, we just pull that data out of the factory calibration. But if we're using aftermarket injectors, that data's got to be right to begin with.
Yeah, and that's one of the things, if I can just jump into something right here. If you buy a set of our injectors and you open up inside here, there's the little card that tells you this is where you need to go get the Ford data, for that set of injectors. And if you ever go out there on the internet and go look at this data, it's pretty complex. It takes a lot of research. It takes a lot of working out. And while here we're in a Ford environment, we do this for GMs and Mitsubishis and Subarus and all of that, and that's what we specialize in. We want to make sure you have data like this kind of stuff, that we provide with every set, so that you can tune successfully, and then also the OE data that you need to use when you're working through your tune.
Hey, your graph lays it out right here. These little spikes are variability, and Joe, our favorite one here around the shop is, well, I bought 80-pound injectors for my car. They're only like $350. You don't tune those? No, for the most part, no.
Yeah, I was going to say on E85, where it's not as, I wouldn't say it's not as critical, but you're dealing with so much more fuel mass, it's not as much of an issue at idle. But on gasoline-based fuels, 80s can be a nightmare.
Yeah, and the 80s just weren't designed with good low pulse width control. I mean, the engineer that we know that was involved with the design, he'll openly admit, yeah, they have no control below 2 millisecond pulse width.
Yeah.
Right.
And that's, at idle on gasoline, where's your injector usually operating pulse width wise?
Yeah, it depends on the size, of course, because as the injector gets bigger, that pulse width shrinks dramatically. But typically on something like 1,000 cc injector, you're looking at 1 millisecond.
1 millisecond.
Maybe 0.9. Depending on how tight you're pulling it down there. And then on these big injectors, if you get into 150-pound injector, you're looking at less than half a millisecond. And if you don't have the data there, then and this is something that I like to explain to people about that short pulse width area. Your dead time or delay of opening and closing an injector.
How long it takes the magnet to charge and open the
to
valve?
Open the valve, have the valve settle, and be in open position is around 1 millisecond. And if you are tuning using a half a millisecond worth of fueling to idle the car, if you have inaccuracy over that dead time, let's say it's 20%, so from one injector it might be a 1 millisecond dead time, the other one is 1.2. Now suddenly that 0.2 of a millisecond differential between the two injectors over your half a millisecond pulse width is a 40% error in fueling.
Yeah.
And you know, you're not firing that engine with a 40% error in fueling.
No.
And that's where all of that, critical matching of the injector comes in. And
I mean, even at a 1,000 cc injector, that's approximately 3 times the size of a factory injector.
Right.
And at idle, these modified cars, they use about the same amount of fuel at idle. They don't care how much boost you're running peak. At idle, they're just sitting there idling.
Yeah, especially on some of like the F-150s where they're idling at 500 RPM.
Yeah.
You're not moving significantly more air, even if you have a 3+ liter supercharger at idle.
And that's really the challenge of, for people like you that manufacture these injectors. These things have to operate over a huge range, way bigger than even the factory parts.
Right, and that is where we are the partner to the tuner to make sure that you have something usable for that application. Yes, that same injector might work great, in a just OE setup. At the moment that you are looking for bigger, more flow, then this short pulse width critical area down there becomes, so important to you have a good product to put out there. If I don't know if it's okay here to go into a little bit of like how we do that matching. Again, Chris, if you can go to that first scatter graph there. If you look at that, that is approximately 200 or 300 injectors there. Every little blue dot is an injector that's been tested on the flow rate on one side and the dead time, which is the delay in opening and closing, on the other axis. And that's what it comes from Bosch. That is as good as it gets when you just buy a bunch of injectors. And if you're buying injectors off of eBay, maybe, where somebody's just repackaging and sending them out, you might end up with an injector that could be on the outskirts of that circle. So if we carry on, the next level...
And let me add that, that's just one injector that's on the outskirts.
Yes, you could end up with multiple of them in there and have real problems. So the next level is somebody who does basic flow matching, and now you're in the realm of that green circle over there. Okay, now you've eliminated some of the outliers over there, and you're looking pretty decent. But you can still have as much as a 30% differential in the dead time, in the delay in opening and closing. And like I said before, that can get you 40, 50% error in fueling at the short pulse width. Does it matter at wide open throttle? Not a thing. Your car will look great when you're putting big power down.
Exactly, and that could be on a cylinder-to-cylinder basis. If you're getting each individual injector in one portion of the scatter plot.
You get a misfire on one cylinder, not on the other, everything looks cool. Then when we come in, this is what we do, and why we give you all this data with the set is now we're looking at those little blue circles in there. Every set of Fuel Injector Clinic injectors is within that little blue circle over there. And if you look back at that big red circle and now at the little blue circle, now you realize, okay, wait a minute, I could have problems when I'm in that big red circle and that's all I've got. And and that is, and we provide you all that data with every set in the box when it comes to you. In some applications you can use that data, in others it's just there to make you feel comfortable that what you have, every injector is serial numbered. You can reference back to the data that you have. And then also there's the general data. Actually, Chris, do you mind going to that data match technology? So just to show you, that's the whole flow sheet. Everybody, if you can see that on there, that's the entire flow sheet of what you get with every set of injectors. And then the next level, at the top there, those bar graphs are the actual slope flow, which is the flow rate.
Which is that's the old-fashioned, hey, I tested your injectors, they flow this much.
Right, would only be over here, and then, there's the actual offset values in the green bars, and that, again, we give the percentages difference in each of those.
So,
super tight.
So as a tuner, just glancing at this data, I can see very quickly, at wide open throttle, these injectors are all going to fuel within 0.9%. And then the offset matching data, that's the critical idle control, dead time type stuff you were talking about.
Right.
And that's within 0.7% from injector to injector.
Right. It's just one component. We're not trying to say this is going to solve anything for you, but it's one component that as a tuner, I've got a solid item here that's giving me what I don't have a variable. I'm not introducing a variable here that is going to be a challenge down the line somewhere. And sometimes you're lucky, and it's all good. If you can buy a eBay set and you can be lucky. But do we want to trust our motor to luck?
Yeah, exactly.
Well, and like you said, eliminating variables, and then as tuners, we can just focus on making the whole car run good, not doing troubleshooting.
Exactly.
Which
Right.
we've gotten pretty good at troubleshooting. That's how remote tuning, how we make it work.
Exactly.
But still, time is money, and customers' frustration is important to not get to that. Solve problems, figure them out. So you supply this data on every set of injectors, and then on your website you've got a lot of this converted into what loads in the specific ECU.
Correct.
Yeah.
Correct.
And that's what's really valuable. That takes it even another step further. Okay, I've got this data. How does that apply to my particular ECU? Because all the OEMs, they do it a little bit differently, right?
Every set of engineers has worked their own way to characterize injectors.
Which is just an electromagnetic valve.
At the end of the day, yes. And all of this has come through the evolution, obviously. We look today at today's the standalone ECUs. They still have these basic tables, which basically is like a dead time by voltage, and then maybe by flow rate and whatever. And we started there. The OE ECUs had that, probably late 1990s. But little by little, they learned. Okay, wait a second. If we match the data better on the pressures, measure the pressures or measure atmospheric or whatever, and each time they add a table, and now we're with the kind of tables. If you look at those spreadsheets, it's like, oh my gosh, there's so much data there, and it requires somebody like us to bring you this because we spend hours researching and converting that. And you need to do other things. You can't be an expert on every little area.
The chassis dyno is our tool, and the racetrack is our tool for producing quantifiable, measurable results. So what is your tool when you're building these injectors?
Well, we have spent over $100,000 on a specialty bench and specialty software. The biggest challenge really was because there is no equipment out there. Big OE suppliers like Bosch and Siemens and Denso and whatever, they've all built their own equipment, and there's, we can't go build something like that. So we had to find somebody who would write us the software to test these injectors so that we can even produce this kind of data. So there was a huge learning curve going into this, and we're very proud of what we've done over the years to be able to produce this. And I think to date we're the only people that have a sheet like this in every set of injectors. That actually gives you the data with that, and it's in part because we've spent so much time to build these equipment.
So you've built like a specialty flow bench that spits out a bunch of data. You see them at some of the trade shows and stuff. They've got, you mount your injectors and they've got like a graduated cylinder, and it pulses the injector and fills it up, and all right, here's your flow match difference from injector to injector. I imagine you're way beyond that.
We are very, very far from that. We started there too, and very quickly we learned, wait a second, this is not, what we need.
It's not the whole picture.
This is not the whole picture. All we're seeing there is something like wide open flow. If you think about that, the pulse width for idle, there's probably about, I'd say, 2,500 pulses in filling a teaspoon.
Probably.
So now imagine that in that graduated, cylinder. You take forever.
That puts it in
sitting there
perspective.
for a bunch of minutes to even look at one injector, and that's at one pressure and at one voltage. Now, take that over, what you require, all the different pulse width lengths, all the different pressures and voltages, and you'd sit there forever. So our benches are like super, super, fine measurements and very quick. It has logic software in it that can determine when the pulses that are being produced are equal enough that the measurement is considered accurate, and so on. And it was this kind of stuff that required a lot of R&D and learning on our part. And we're still learning every day. There's no way we claim that this is it. We are learning every day about
the engine's ability to make horsepower just keep going up, so you've got to keep supplying them with more fuel.
We see that all day long. Just more and more fuel, and the street car today, it's almost like nobody's happy, under 800 horsepower, right? I mean, where do you guys think that level is at now, where people are just sort of saying, okay, I'm in the game?
I'd say if a car doesn't make over 590 wheel, it's not in what we consider the game.
Yeah,
for
it's
most of our
not. It's not in a
customers.
game, and it's probably at the back of the pack with 590 wheel. I mean,
Right.
800 is the new 600,
Yeah.
and we're just still talking street cars here. You get into some of the all-wheel drive exotics and stuff. That's just,
If you're not making over 1,500 in some of those cases,
yeah.
you may as well just go play with Mustangs.
Carrie, are you looking at me for questions?
Yeah, we have a number of questions that are kind of stacking up.
Okay.
So,
What were you going to say, Jens?
Yes. No, I was just going to say that's what we're getting challenged with every day is that these cars make that kind of horsepower and they want street drivability. They don't want to be sitting at a traffic light and the car dies.
Yeah.
And I know that's a challenge for you guys in the tuning world, and that is our challenge to provide you with
With a
the
hardware that
ability
can get
to
it
do
done.
that.
John, you want to go ahead and start?
Yeah. JP wrote in, he wants to know, he's building a killer 3-valve setup, a 4.6, with a Department of Boost manifold, and he's going to run a Gen 2R or a Gen 3 and wants to know what size injectors is best to make 700 at the tire.
Did you say in what fuel?
Did not.
All right, so that's going to change, and maybe the easiest way, since none of us are sitting here with a calculator for that, on our website there's a calculator that you can go in. You can put in your type of fuel, whether you're NA or boosted and so on, and you can go see in the calculator what range. And there's a range. You can probably get away on the bottom end with a smaller injector, on the top end with something bigger.
Right. And so what's really important in those calculations is how much base fuel pressure you're running,
Right?
how much boost, and then RPM sealing of the engine. How high it's going to be spun. That matters quite a bit too, right?
It matters in the way that the horsepower produced is at a certain RPM. At the end of the day, you need a certain amount of fuel to make a certain amount of horsepower. So that will be your, the fuel, absolutely, the fuel pressure, the base fuel pressure, 100%. And, and then, what kind of a setup, are you, boosted or, are you in NA? That typically is the... RPM-wise, the injectors are pretty cool. They'll take anything. Most injectors in motorcycles, 2-strokes, are the same injectors that are in 4-strokes, so they can handle, 15, 18,000 RPM.
And the reason I bring that up is because there's, in the Mustang world, the Coyote's the high revving, essentially the motorcycle engine. The rest of the Mustangs are only spinning 6,000 RPM. And I feel like those cars can get away with a little bit smaller injector because they've got more time to inject the fuel at that lower RPM.
And that is correct. Your
Okay.
time available, absolutely. In that case, yes. I did not make that connection.
And it
for a
wouldn't
second
be
there.
it wouldn't be a big deal if we didn't have the Coyote and then everything else in the
Right.
Mustang world. But we do. Now, to answer the original question, most of our customers are going with a 1,000 cc injector, which is around 95 to 100 pound an hour at 40 psi of fuel pressure.
And that would likely cover him on E85 and pump gas at that
Yeah.
level.
Yes.
1,000 is kind of the jumping off point for an injector of this quality and price and everything, it seems like.
Yeah.
Yep, and I would agree with that. It's also an injector that will handle all the short pulse with the idle very healthily. Like, you can expect stock-like behavior at that. You can expect that until about 120 pound per hour. Once you get over that, there are a lot of accommodations, and as you know, as a tuner, that you've got to make to make sure that the injector can still, follow the short pulse with it. Does it help everything we do to improve that? Yes. But they are challenges when they get really big. And maybe there's something in general knowledge we can throw out there to the customers. Don't buy an injector it's so huge so that for every goal in your dream you're covered, because there's compromises.
That's where I was going to go next with that. Yeah.
Okay, Marty wrote in, he wants to know why he should choose FIC over a competitor like ID.
Well, there are good injectors out there. We don't say that our competitors don't make a good product as well. We have this data that we provide that is second to none. And also, we're the customer service people. You want to call us, you have a question, we're there to answer, any questions you have. And we have a lifetime warranty on our product, that just makes you comfortable in knowing that you can, call us anytime and even down the line and say, hey, why are my injectors doing this or that? And we're there for you with the warranty. We're there for you with the information.
What all does that lifetime warranty cover in terms of the injector?
We're there with the injector as a manufacturing piece with a warranty that you can just bring to us. The injectors are very hardy little characters.
Right.
They don't really kind of break.
If you run mud through it, that's a different story, but you don't believe it's going to fail as a manufacturing defect or anything like that.
Right, and listen, it's a thing. Some will break, but it's a very low occurrence of that, and therefore we can offer this comfortably lifetime warranty. And you ask, what level do we go to? We'll replace the injector for you if it's failed, for a reason that's outside of it's the way it was used, as you said. So.
Okay, Brian would like to know, are there any long-term negative effects of using E85 on the injectors?
We have not seen that. Our injectors, the Bosch product has all stainless steel internals inside of it, and they can handle all the alcohols. There is a very large injector, the 2150, that needs some special care for it because of its particular makeup. You can read some more about that on our FAQs. And I just don't think in this here if we need to cover that. But no, generally it's just fine. Any alcohol fuels are fine.
The biggest thing we see is just use your car. Don't let it sit.
That is true. Injectors don't like to sit. You get lacquer on the valve, it sits for a while, dries out, and people will say, oh, I tried to start my car back up and it won't start. The injectors are broken. Usually they're not broken. They just need to come in for a service, get them cleaned up, and you're good to go. Like I said, they're really hardy little characters.
All right, Mitchell writes in, he says, my ID 1300 injectors flow less than 1200 cc a minute with over a 3% variance in flow. Is that an issue?
Well, I don't want to speak really too much about other, product. The flow rates on injectors are based a little bit on what type of fluid they were tested with. And what kind of gas are you running, different viscosities and so on, influence all of that. I think as the injector, as long as it makes, you're within the 90% duty cycle, that's something to test and look at. You should be fine. You shouldn't be too worried about what that flow number is. The 3% variance in flow, I think you're in a safe zone. Most the Bosch injectors, when they come out of the factory, are as much as 5% apart. It's probably in an area where it might be a good idea if you serviced his injectors, because 3% is kind of getting to where, that's probably just a tad too much.
And one thing I would bring up is how good is the test? Because 3% is already a pretty small number. How good's your equipment and your testing procedure?
Right.
That and, all right, well, if you're worried about 3% fuel on 3% variance across injectors, what's your airflow variance across cylinders on the engine?
That's something the aftermarket doesn't really talk about, but there are certain race cars and projects and stuff that are being built that will have individual EGTs and potentially individual widebands in a Coyote, because there's a lot of cylinder to cylinder difference.
That, and that's something that even Ford characterizes in the stock mapping on a 11-up car. There's individual cylinder fuel multipliers, and they're using the same injector in every car, and they use that same table in every car. So it's like they're not accounting for injector variance; they're accounting for cylinder filling variance, cylinder to cylinder,
based on intake manifold design, cylinder head design. You could even talk about camshaft design
and an exhaust manifold at that point.
Yeah,
one exhaust runner is a little bit longer than the other and it scavenges a little better. Therefore, the cylinder gets filled or evacuated quicker than the one next to it.
I think the thing to learn, take away from this is don't read into this stuff too much.
I wouldn't, something like that, I don't know that I'd worry about it too much unless it's you're specifically chasing a problem.
Right.
Yeah.
Right. I agree with that. You know.
All right, Peyton would like to know, how are the sizes of fuel injectors determined?
Well, it is basically a flow rate is the primary consideration there. Unfortunately, there isn't a standard out there. There's sort of an accepted industry
Like rule of thumb.
guideline, rule of thumb. So, and we've actually found that in some cases we've had to adjust our sizes just to be in part of the market. But it's a flow rate. At the end of the day, you know, it's a valve that opens. When it's open, there's a particular flow rate produced at a particular pressure. So that's the other thing, you know, make sure you look up and see what pressure the injector is quantified at, because you know different manufacturers may use a different pressure depending on what market they're in. One company provides primarily injectors to the import market where 43.5 psi is the base pressure, most common. Others are in the domestic where often 58 psi is our most common pressure. So take a look at that and make sure you're comparing apples to apples. But other than that, it's testing with the equipment that we have and
Yeah, I mean, use a standard fuel pressure. And what are most of your injectors rated at?
So we're rated at 3 bar, 43.5 psi.
43.5 psi.
And that is, we hope, the primary standard out there.
It's a good number for the Ford world. That's a whole nother spiel about Ford fuel pressures, because that's a moving target.
Yeah.
But yeah, it's a good baseline to compare everything again.
Right, and again, if you use our calculator, it says, you know, what is your fuel pressure? You put that in, and with that, you can just determine to make sure that you have enough fuel. We use a guideline of, you know, no more than 90% duty cycle, so you always have some safe room built in when you use that calculator, and it'll accommodate the pressure difference.
So that's one little tangent I want to run on is, well, my injectors are maxed out. What does that, really mean? What duty cycle is safe? What's not? There's been some stuff printed and, from reputable sources over the years claiming as little as 80% is the maximum safe duty cycle, and I personally don't believe that's a good hard limit.
It sort of came from when I first entered the industry. I heard the 80% all the time, and I sort of asked myself, well, why is that? And I think it was a way to protect the consumer, maybe in a way, because the closer you get, the more you run into danger of running out of fuel. However, the injector doesn't care. Just if we can just delve into real quick what happens at the maximum duty cycle, you're basically telling the injector to open up and stay open past the time where it closes again. So basically, it's a case of, here we are, the valve opens up, and when you get to 97% duty cycle or something, it's on its way down, closing, and your next signal comes to open it again, and it jumps back up there. Is that bad for the injector? No. Is it bad for the car? No. As a matter of fact, because it never closes quite, it gets a little bit of extra fuel.
I see that
comes in there. The problem is when you get to the end of that, the next thing is you don't have enough fuel.
Now your air fuel trace is lean.
Right.
Yeah.
So you go and you get richer, and you go, oh, this is cool. And then one day it's a really cool day out there, and you're making 10 more horsepower, and you're running lean. And that's why it's dangerous.
That's where some of the statements are trying to protect the consumer. If you have a high fuel demand situation, really dense air. I mean, we've been out half-mile racing where it's 50 degrees out. The cars take more fuel in that situation. But, so you say 90% is what you like to see your injectors at.
I think that's comfortable. Just like you said, there's no real reason to be a whole lot lower than that. And you still have some of that room that you're not going to run out of fuel.
And I will say from tuning experience, GT500s go rich as they max out the injectors before they go lean. And the rev limiters are so low on them, it's not that big of a deal. Coyotes, on the other hand, they rev so high that, once you run out of injector at 7,000, It's
Everything goes downhill really quick.
yes, yes. And there's the Coyote's still making airflow, so it still needs more fuel as RPM goes up.
Yeah.
A GT500's fallen off on airflow.
Yeah.
Right. Yes. That torque curve is is important. If you keep growing out there, then you want to make sure that your injector has enough
To maintain.
headroom.
All right, Dorian wants to know, does FIC make a direct injector for the 18 or the EcoBoost engines?
We do not, is the simple answer. We have chosen, in part, not to go in that route. The direct injector is a very difficult character because he's so closely connected to the fuel pump, and in a lot of cases, in many cars, a mapping, a fuel pressure, rising fuel pressures, mapping, and all of that. And it's very intricate. We've seen a lot of trouble with the direct injectors in the marketplace. You know, we're all about science and testing, and when we tested and didn't feel comfortable that we could have a quality product out there, that it was maybe we even saw a route to get the injector to where it needed to be, but what if it worked with this fuel pump, which was not delivering enough fuel? Generally speaking, in fuel pumps in port-injected applications have plenty of headroom, where it's real easy to put a bigger pump in and you got lots of headroom. Well, it's very challenging in the direct injection world to make sure that you have enough fuel to supply. So it was both a pump issue, it was an ECU issue. So we've chosen to be, the best at port injection. It's kind of funny because the market's kind of coming back around to us. We're hearing more and more about the dual injected cars coming back, and we almost have a suspicion that due to the issues that direct injection only brings into the cars, that we may see these dual injected solutions kind of become available everywhere. The standard. And then we're golden because we make a good quality port injector. It's the port injector that you want to increase in size and leave everything stock in the direct injector if you can, if that's an option for you, because that's the one that's critical. That's the one that's living in the combustion chamber, where it's very difficult to maintain.
Very expensive, high quality piece that has to live in
A
there.
very long time.
Yeah.
Right.
And we've been playing around with direct injection, and like he said, it's not necessarily just an injector size problem. And I think, Joe, you calculated the Coyote DI injectors to be around 100 pound an hour.
Yeah, depending on what pressure you're operating at.
Yeah, they're freaking huge. But you've got to have a pump that can supply 3,000 PSI at 800 pounds an hour, and that's where the real, well, no, actually it wouldn't be. It's duty cycles are a big thing.
Yeah,
with
duty
DI.
cycles on DI are significantly different from port
Well, yeah,
injection.
because the injection window gets much shorter.
It's basically a quarter, or not
Correct.
not a
a
quarter,
little bit
but
more than a quarter, but it
Yeah.
isn't even. It's not even half.
Yeah.
So I hear like 38% of the window. Kind of thing.
So we know these are all four-stroke engines. You can only inject fuel during one of those cycles with
when you're
DI.
direct port, or direct injection.
With
Direct
port injection, you can spray fuel at that valve the whole time. It'll make it in there eventually, especially at wide open throttle.
Exactly.
Right.
That's a little bit into it, Dorian, and we can talk about that more another time.
All right, Adrian would like to know, are your injectors sold as CCs or in poundages? And can you please explain CC versus poundage?
Sure. Our injectors are all listed by cc's per minute, and it's really just a different value. The calculation between pounds per hour and cc's per minute is 10.5. So if you just want to use divide by 10, then you're really close to the number. So something that's 1,000 cc is roughly 100 pound per hour. It's really kind of 95, but you're going to be close enough where you're good with that number. So that's really just a different way of listing it. And on our website, we list both. If you go in and you look at our injectors and you go down the list, we just need to read a little bit further than the first title, and it'll give you the pound per hour, so that those who are comfortable with that, can see those numbers.
Yeah, so basically it's like looking at a ruler that has two sides. It's inches and millimeters. It's the same physical measurement, just
Right.
with two different units.
Correct.
Yeah. All right. Chris is asking the million-dollar question. Is it possible to have too big of an injector?
Yes, yes. We kind of touched on that a little bit earlier. If you get so big of an injector that you're really struggling with that short pulse width, you're making it a complete bear for the tuner to get proper fueling at the shortest pulse widths, and then you're really not using the upper end of the flow of the injector at all. So if you have goals of 1,000 horsepower, don't buy a 2,000 horsepower injector because you're just gonna make trouble for yourself. So,
I would say within reason for most of our customers, if you're running a gasoline-based fuel, a 1,300 cc injector is typically the limit of what a controllable injector is on a gasoline-based fuel. If you go beyond 1,300 on a gasoline-based fuel, plan on having problems with idle and low throttle drivability and consistency of injector.
Yeah, a little bit of that, and in different cars that plays out in different ways. Sometimes it's a compromise where you just got to idle a little richer and then you get the stability back. But there's going to be a compromise. Whereas, as you said, under the 1,300 cc, 120 pound per hour, you can pretty much safely expect with a decent injector, that doesn't have other compromises going in, that you should be able to get the car to idle like stock.
All right. Adrian would like to know if you could explain injector duty cycle versus pulse width.
Okay.
Short version, it's basically the amount of time the injector is open is the injector pulse width, and then the duty cycle is reference versus time or a unit of time.
Well, it's reference versus available time. So you had mentioned, Justin, that at 6,000 RPM, you have more time available than at 8,000 RPM. So an injector that is at 90% duty cycle at 8,000 RPM is open physically for a shorter time than an injector that is open 90% duty cycle at 6,000 RPM, just simply because of the time available. And just give a quick idea, at 6,000 RPM, you have 20 milliseconds available in the 4 strokes or 2 revolutions of the motor. So that's 20 milliseconds of available time. At 90% duty cycle, you will have an 18 millisecond pulse width.
And I know some ECUs allow you to data log one or the other, not always both. I remember there was a trick on the EC5s to calculate duty cycle based on pulse width and clock ticks, which was a favorite of the EC5, versus RPM, and you come up with the available, with the duty cycle based on
And
that.
some of the other ECUs will do it versus pips, which
Oh,
is
okay.
kind of the same thing, kind of
I
not.
think so, yeah.
Killian wants to know, since the injector opens and closes extremely quickly, but does the fuel flow or the volume of fuel change just as quickly as the injector open-close time?
That gets into the fluid dynamics of it, which that gets into the short pulse width issue. The moment that the injector is open for a reasonable period of time, let's say, in most injectors, a 1,000 cc we talk about here at like 1.5 milliseconds, after that, the flow is extremely consistent. So at that point, we can predict the flow really well. It's in that partial opening phase in the beginning that we see all the things of, the pressure's got to overcome, the spring opening, it's got to overcome the pressure that's behind it. Then the fuel starts to flow around the valve, through the diffuser plate, and so on. And so, yes, there are resistances there in play and whatever. And that's why this whole short pulse width matching thing becomes so critical when you get into those areas, which, by the way, none of the stock injectors, this is one of the things people will say, I'm having a problem at idle, I put my stock injectors back in and I have no problem. So it's your injector that has the problem. But wait a second, you're working with a pulse width that's a quarter of the pulse width that you have on your stock injector. That injector is in a completely stable phase at idle versus the other one that you've put in that isn't. So if you're not exactly right with all your tuning and quantification in the big injector, then you can't just use that stock injector as a reference.
And something that has been explained to me is that Ford has a high and low slope in the calibration, which models the flow potential of the injector. They model it slightly differently at very low flows because of what you're talking about.
That's exactly the reason for that low slope. Is the fact that that injector during that partial opening phase is flowing completely different to the main part, which is the constant flow. Going up.
John would like to know, is a 60-pound injector too big for a 2015 Cobra Jet intake on E85, considering going turbo a little bit later?
Oh gosh, Joe. Do you want to speak to that one, or do you want me to speak to that one?
Well, it depends on which 60-pound injector he's talking about.
So the 60s that we think you're talking about have no business in a Coyote.
Yeah. If you're talking about, I think it's an LU60.
Yeah. Leave them for 03 Cobras. They work good in that. And honestly, a Coyote with a turbo will make so much power, it'll max out a 60 like that. And it's a perfect example of using an injector that's appropriate for what you're doing now, and then just buying a different injector in the future.
Exactly.
All right, Killian wants to know, what is the injector data you are referring to when you're tuning a car?
Well, I
So
guess there's...
I wonder if he's talking about the stuff that you guys have
Right, there's
available
two, I
on the
was about
website.
to say, there's two different areas there, and that's going to depend whether you're talking about a stock ECU or you're talking about an aftermarket ECU. The stock ECU data is what's on our website. You need to go over there, and that's just simply because the spreadsheets and everything are too big to print on a piece of paper, but then also would be useless there because you'd be entering all these little data points in your thing. So it's much easier to go and copy and paste from the spreadsheet into your ECU and be ready to go. Conversely, on what's on the actual sheet with the injectors is if you are using a standalone ECU and you just need that simple, pressure versus voltage, offset table, and you can, and the flow rate, of course, and enter that manually because that's only 30 or 40 cells that you have to fill.
All right, Dozen would like to know if FIC is a new brand of injector on the market.
That is a resounding no. FIC has been around since the 1990s. I have been in charge of FIC since 2007. So we have been around for a really long time. We did grow out of the import market, which is why a lot of people in the domestic market may not have heard of us yet, but we are, very quickly becoming known there and producing good product. And like Justin said, he's known about us for a while.
Yeah, since at least 2010 or 2011.
All right, Peyton writes in, and we touched on this a little earlier, do you design fuel injectors differently for a direct injection engine than you do for a port fuel injected engine?
Yeah, they are two very different animals. First of all, let me just say we do not design injectors. Nobody in the aftermarket does. The actual design of something like that and producing it is in the realm only of the suppliers to the OEs who make millions of these injectors at a time. So the design that you're always getting is from a quality-based product and a quality company. But yes, in their character, they are entirely different animals. The one has got a fire into a combustion chamber at 3,000 psi, and the other one has barely 50 psi across the injector. And so yes, they're very different, and also very different in cost if you go out there and take a look at that.
Okay, Arnie would like to know, do injector cleaners help? Do they work? And if they do, what brand in particular do you feel is the best?
We are not big fans of like in-car or fuel-based injector cleaners. We do not see that that they have got any great effect. If you're into high accuracy and knowing what your injector does for a performance application, you should probably send them in and have them ultrasonically cleaned and tested by a reputable company like us.
Okay, Mike writes in, he's wanting to know if he adds a 100-shot express plate kit, will he need to go to a larger injector or fuel pump? Thanks, and did not put what engine he was running.
That's a
If he's talking like a 5 liter or 5.4, I'll do 5 liter since most of the GT500 guys don't do nitrous. Most of the 5 liter guys do. If you're talking about 5 liter, do you absolutely need to put a bigger injector in? Not necessarily if you're going to keep the window of operation low. If you want to put like a CJ manifold on it and rev it pretty high, an LU47 would be a really good injector to put in there. And I should differentiate that if it's a wet kit, you really don't have to worry about putting a larger fuel injector in there. If it's dry, definitely put a bigger fuel injector in there.
I mean, I think most of the wet kit, most of these nitrous kits these days, especially the ones with specific plate kit fitments and stuff, are usually wet, right?
Yeah, they're usually wet.
So they bring their own fuel when they're wet. So what
Yeah,
that
basically
means,
has its own fuel injector. If you're wanting to significantly increase the RPM window in which you're operating, like I said, with a Cobra Jet manifold, you should probably have a different injector in there to begin with, but especially more so if you're going to be using nitrous.
All right, Nick writes in about his 2007 Shelby GT500. It's got a JLT 123, VMP triple bypass heat exchanger, VMP tune on a stock M122. He's going to be adding a Trinity TVS 13 to 14 500 injectors, a 90 millimeter idler with a stock 60 millimeter throttle body, stock exhaust. Will he have enough injector, and how much horsepower can he make?
Yeah, you'll have enough injector on 93. Depending on the pulley size you go with on the Trinity, if you're on the stock 267, you'll probably make 620 to 640. If you're going to go with a 2.4 upper pulley that we sell for those, probably closer to the 650, 660 range on a reasonable tune-up on 93.
Yeah, I mean the 56s, as long as you keep the setup like that, they'll be big. They'll be big enough. But if you put a lower pulley on them, you'll be dancing around the edge of those.
Okay, Slab Shack writes in, what is your take on companies offering to modify stock fuel injectors?
There's a place for that in the market. I think if you're building something that is not very highly strung, maybe you can get away with that. The problem is that when you modify a set of injectors, you necessarily only have the same amount of injectors to start with. So your matching is basically zero. And this goes back to that first graph, the scatter graph that we showed. You're at the mercy of where those 8 injectors that you send in end up. And since the person doing that is unlikely to have more injectors or be prepared to trade some of yours out, you're going to get back whatever it comes back at, and that can be a very wide variance. And you should at minimum flow those injectors yourself or send them to some place to have them looked at so that you know what you're putting in your car, because you can be on the edge there.
And then how do you tell your tuner exactly what those injectors are? You know, that's where these guys add a ton of value, is they produce an injector and they know what it flows and they know how to populate all the tables to tell the computer exactly what it flows.
And it's repeatable.
Yeah.
Yep.
So
All right, Chris writes in, he'd like to know, since most shops sell fuel pump voltage boosters to boost fuel pressure, how does voltage and pressure changes affect the injector?
Well, the boosters you see on the market don't really change injector voltage. They change total fuel pump flow at a specified voltage. So like when the stock pump's operating at 13 volts, it flows, let's say, 255 liters per hour of fuel. If you run that same pump at a higher voltage, it has a potential to flow more fuel. So you can bring that 255 liter per hour pump operated at a higher voltage and get as much as, we'll call it 280 liters per hour out of it. So when you're talking about fuel pump voltage boosters, try not to think of it as you're putting more, I don't even know how else to
you're
describe
making
this.
more fuel available, really.
Yeah,
And
you're not necessarily increasing pressure
You're-
at the same
Yeah.
fuel flow.
And that's the thing. You still have pressure regulation, so your pressure is still going to be similar to stock.
It's just basically a tool to make sure you have enough fuel. And injector, specifically, as long as the voltage to the injector remains constant and you're not drawing down your system somehow or another, the injector will be quite happy. to operate with that.
All right. Arnie wants to know, how often should you have your injectors cleaned and or tested?
Well, that has a lot to do with what you're doing. You know, basically we said like injectors that get used all the time in a car and have, you know, clean fuel coming in, and you change your fuel filters at a reasonable interval, or at least check what's in your fuel filter. You shouldn't have to do it very often at all. Conversely, if you're taking your car down for the season, and you had E85 sitting in there, whatever, it's probably a good idea to have your injectors clean before you head back out on the track, and make sure that you didn't have some sort of buildup or something's blocked a part of the injector. But again, they're typically hardy, but it's good. It has a lot to do. We see the most problems with people who repeatedly take their motors apart. People who are racing, blowing them up, going back in. And that's why for a lot of our sponsored vehicles, we provide free service for them, because we rather have their injectors come back than be blamed for something when they started back up and went racing and something was in the injector and so on.
Exactly. So I think what you're trying to say there is that if you're using an injector in a stock style manner on a stock vehicle, don't worry about doing it too often. But if you're doing what we call race car things,
right,
do your maintenance and make sure that all your ducks are in a row when you're dealing with stuff like that.
Right. Because while the injector is a sort of, it doesn't make any power, it can sure blow your motor up pretty quick if it's wrong. It's got something in it.
To that same end, what do you guys typically charge for like an 8-cylinder engine to do a basic injector cleaning? Do you have like any flat rate pricing on stuff like that?
Yes. Cleanings are $25 per injector. And we have a pretty quick turnaround time. They won't be with us for more than 3 days, and we have rush services on top of that if you want. We replace all the O-rings, all the filters, and we give you a flow sheet back that gives you all the data for the injector. What each one flowed. We number them as they come in.
Okay, sweet.
All right, Keen writes in, he has a question for Joe. He's got a 2013 GT with a built bottom end. Says he's going to purchase a Gen 3 blower. He will be running 93 octane. Currently has a Gen 1 with an ID 750. Will he need to upgrade to bigger injectors?
If you plan on staying on a gasoline-based fuel and keeping it below like 7,800 RPM, you should be fine. But just keep in mind, being that you're going to be running 93, you're going to want to be not necessarily conservative with pulley size, but just make sure that your pulley size is commensurate with your octane. So try and stick around like above an 85 millimeter pulley on 93.
And compression ratio too, depending on what compression ratio his built motor is.
Exactly. If it's a stock compression built motor, the above an 85 millimeter pulley would be a good rule of thumb. If it's a low compression motor, kind of a case-by-case basis, get with us on that. We can take a look at the entirety of the setup on the car and see what we can get away with in terms of pulley size for your octane.
Okay, Stephen would like to know, what is the biggest injector that FIC makes?
So the biggest injector we currently sell is a 2150 cc injector. I think that on a V8 we should be over 2,000 horsepower to the wheels on that. So it's not a very common injector that we sell in that realm, pretty much a race car specific only. Yeah, that's pretty much it. That's the biggest injector that we sell. And part of the reason for that is that it's very controllable. That is a specialty injector. If I just go into that real quick, it's an injector that was based for a natural gas engine actually, and we're repurposing it to flow fuels, liquid fuels in there. And the reason why we like that is because it has a super fast opening and closing time, which is necessary for any kind of decent idle and control at the bottom. And for the size of that injector, it has surprisingly good control at the bottom. Not to say that it doesn't have compromises, it just means that it's better than most. And pretty much what we find in any injectors being sold out there above that size is that there's some significant issues with idle, and so the other injectors in the market bigger than that don't really supply anything that can be used in the street anymore.
And those are, that's a high impedance injector.
Yes.
So that's like a stock factory ECU, stock ECU, type situation.
Right. Right.
Okay, Emilio wants to know, with no vacuum leaks, what can cause one side to run richer or leaner apart from having a bad injector?
A mechanical issue inside the engine where whatever's going on in the cylinder isn't allowing it to completely combust. All the fluid going into the cylinder.
Yeah, cam timing off, ignition problems.
A valve that's burnt, whether it be intake or exhaust, typically exhaust. Ring sealing.
And then from an injector side, what I'd throw in there is to say, remember, you bank to bank, you're still talking about 4 injectors on one side and 4 on the other. The chances that all 4 on one side are doing something completely different than all the 4 on the other side is kind of unlikely. I mean, if you have one bad injector, you're rather going to see a misfire or something like that than a bank-to-bank issue between the two. And it's always a good idea to just, if it's relatively simple to switch the injectors over, if you're suspecting them, move them around a little bit, see if your problem follows the injector, and at least that's some indication.
All right, Joe is writing in and he's asking, it might be a little too soon to ask before testing is done, but what size injector would work best for the new 0304 Cobra running the new 265 on E85?
I mean, we don't really have to do any specific injector testing with Gen 3. At the end of the day, it's an air compressor moving more air than it was on Gen 2, so you just need to make sure you're getting an adequate amount of fuel to go with that. If you're on E85 and you're really looking to turn Gen 3 up, you're going to want to be up around the 120 pound a minute injector on a stock ECU on E85 that's just straight out of a pump.
All right, David is writing in. He has a 17 Roush 5.0 with a 2.3 TVS with a VMP Phase 2 upgrade. He just ordered the JLT cold air intake and a 79 millimeter pulley. Will the 47 pound injectors be okay to run the 79 on 93 octane?
Yes, depending on the RPM that we're turning it at. Most of the time that I see someone order a tune for a 11 to 17 Roush car, and I see that they didn't buy injectors, I'll typically send you out a note that says, hey, because you're not changing the injectors, I have to bring what we would normally have the rev limiter set to down to a safe operating window for the 47 pound injectors. Sometimes I don't always have the time to email every specific person and tell you, hey, because you didn't buy injectors, I'm bringing your rev limiter down, and I just do it, and you have a rev limiter approximately at 7,200 RPM if you have 47s.
Okay. Arnie writes in, he wants to know if Torco or other octane boosters can damage injectors and or spark plugs.
This would be a good question for you, if anyone's going to see it.
I have not seen, the injectors really struggle with any kind of fuel. Again, it's all internals that are all stainless steel. You can pretty much put anything at them. The biggest thing is that we see that actually influences an injector is methanol, because methanol has no natural lubricant in it. So by the time people run methanol, we always say look for an additive that puts some lubricant back into the system. But that's really the only area where we have a fuel and mechanical failure related issue. And even that really belongs in the older generation, pre-2005 injectors. These EV14s, we don't even really hear much of that anymore.
Do you want to speak to the spark plug side of things, Justin?
Yeah, I mean, we pulled some plugs out of a car recently. The owner had ran Torco for a couple of years. They looked like they'd ran Torco. I'd say it's, what I tell people with fuel additives like that is more is not better. Just use just enough, and that's that.
Keep it within reason. Don't pour 3 bottles of Torco into 5 gallons of fuel.
And change your plugs a little bit more often, but it's not like you have to change them every time you run it, just a little bit more often.
Yeah, and I've never really seen Torco foul a spark plug so much as I've just seen discoloration of the plug due to running Torco.
I just want to let you guys know it's about 2:40. We have a number of questions that are not injector related necessarily. Didn't know if you wanted to touch on them or if Joe maybe wanted to stick around after and answer some questions.
I can answer questions individually. If they're not injector related, I'd like to try and keep it on topic with our current guest. Try and keep it injector-related stuff. May as well focus on that stuff.
Okay, well,
so,
with that said, then we're pretty much caught up on injector questions.
okay. Do you want to?
Okay.
I don't believe we covered it, but you had mentioned earlier that you guys are working with. Is it Pro Stock with some of your fuel injectors?
Yeah, I mean, this is just something we like to share because it's I feel a significant thing. The Pro Stock changed over to fuel injection about 2 years ago, and we were contacted by one of our technical partners, which is Holly, who sponsored the ECU and the injector system in there, and they had been informed about what level of testing we do, and they wanted that to be provided to the Pro Stock teams, knowing that they would want, you know, the absolute best data to work with, because those guys are chasing every last half horsepower. And so they knew they were going to get those questions in. So we provide all the data for the teams. Every set of injectors is serial numbered for them and is actually tracked, because they have to run you know, a spec injector basically in there. And we've worked with some of the teams on there, and they're just really happy with what we do. And it's just a little, you know, a nod to what we do. You know, if somebody at that level is satisfied with what we do, then I think you know
That you're doing a
we're
pretty good
doing
job.
something that's, you know, as much as you can for argument's sake. And it's been very educational from, you know, to get back data from them and information about what we do. So that's been a really cool partnership that we do with Holly and the race teams that we work with there. So it's very exciting for us to work in that realm.
Okay. Is there any other questions or any other topics like these, what look like injector harness adapters?
Yeah, maybe we can just go real quick over, you know,
Here, I'll
what we
throw these
do,
over
the different sizes of injectors. You know, we make injectors anything from 365 cc's all the way to the 2000 cc. So whatever you need for different applications. We make sure that we have all the little plug and play adapters that you know, make sure that you can have if you have a different plug on your car than what comes in here, you know, you can just put the adapter on and change it over. That's something you can just order even on our website, or talk to us if you're not sure what you got. You know, if you are wiring in a harness, we have all the harness plugs for that. You know, it's just something that makes it easy. You know, you select the injectors by, you know, the type of car that you have, and then just select the size and everything. Make sure it fits. So yeah,
And
that's.
I've heard you mention EV14 a couple times. For the people that don't know, what specifically does EV14 refer to? Is that
So-
the connector type or the body length?
It is actually the evolution of injector from Bosch. So EV1 started as the first injector that Bosch made, and EV stands for Einspritzventil, which is the fuel injector in German. And so, you know, people think of what does it all mean. So the EV it just means this was their fuel injector that they made, and that was the first evolution. And really, the only ones that really came into the industry were EV1. EV6 and EV14. EV1 were those fat body styles that we still remember from the early days, and then came the ones that were all colored plastic. There were some green ones and gray ones and so on.
Pink ones and orange
pink
ones.
Right? Those were the EV6 ones.
Yep.
And then now all these black ones is the EV14 evolution. And it is by far the most popular injector out there in the OE world, and we can see why. When we test other brands and whatever, we see why this injector is such a nice quality, and that's why we use it as a base for all of our products that we put out there. And then the plug differences are, of course, you know, this one is the most common. The US car plug is what its official name is. Then the other ones that are common to the mini timer or the EV1. It's, you know, people associated plug types with evolutions of injectors. In the beginning, the EV1 injectors came out primarily with that square mini timer plug, and so it became known as EV1, even though that really referred to the injector. So Today we see this U.S. car plug as by far the most common in the domestic market anyway. And I think, does Ford even use anything else that you know?
I don't think so anymore.
Like 99 to 04 GTs. I want to say that those are, am I
Mini-timer.
thinking of it? Yeah, mini timer. I was going to say, is another
Yeah.
name for US car Jetronics, or is Jetronics the other name for EV1?
Yeah, other name for EV1,
Okay.
the Jetronic or mini timer plug.
Okay.
So
it's
yeah,
all
the
same
9904
generation.
GT would have been an EV1 or Jetronics or mini timer style connector, whereas the Cobra of that same vintage would be the EV14 or US car style connector.
Yeah.
Maybe something else I can just share here real quick. What we hear, people calling us and saying, "Oh, I can't see my serial number on the injector." Well, these little ends here are just. Am I in the picture? Let me just say, these little ends are just extenders, and the actual serial numbering and everything is on the injector underneath that, and both the top and bottom come off. The tops here have additional filters in them. There's an internal filter in the EV14. Every EV14 has an internal filter inside it. The reason why we put a second filter there is because of, as I said, unfortunately, a lot of people who change parts out on their cars a lot and pull them on and off, they get things in it, and if you get it in the internal one, you can't replace it. We can try and clean it, but if we can't, you've ruined your injector. So we rather have you ruin, a $1 pre-filter than, and it does nothing to the operation of the injector. So we make sure we put that in and help people out where it's a cheap fix when you did get something into the injector. But that's a question we get a lot. People don't know that these are just simple adapters that we can
Can
pull
you
on and
buy
off.
just that top hat adapter with the filter built in? Or is the filter built into this top hat adapter?
Well, we put it in, and when we sell it, it has the filter in it. We don't generally just sell the loose parts simply because we don't get a lot of call for that. But yes, you could potentially just buy that, or if let's say you bought a set of injectors and it was in a car that needed the shorter setup, and now you're putting them in a car that needed the longer setup, you can call us and we'll take care of you and get you a set of adapters that makes this an injector that now fits into the older Fords. I think had the tall.
Yeah.
Well, there's still even some now, right? That still have the long.
Yeah, the
Coyote.
height.
the Coyote.
So yes, and it's relatively easy to adapt over.
Okay. Is there any other questions about injectors that you had specifically,
I
Justin?
don't think so. We covered a lot.
Yeah.
One more question.
Yep. KCal83 writes in. He's got a 2011 Mustang GT with an 82 millimeter pulley. I'm guessing on one of our TVS Phase 2 actually. His question is about fuel mixing: E85 and 91 or VP race fuel and 91. I'm forced with 91 octane with my Roush. Should I play the mix game or go straight E85 VP or do meth? What injector is safe?
From a mixture standpoint, I prefer not to see mixtures because at least with the way the ECU is set up when you're running a blower cal, you don't have the inferred ethanol content logic enabled in the blower cals, but you also don't have an ethanol content measuring device in the fuel system. So from the tuning side of things, when we're tuning a car for blended fuels, it frankly can be a pain in the ass because you have to infer the stoic point in order to make accurate adjustments to all the tables you need to make adjustments to. If you do not infer the correct stoichiometric air-fuel ratio for the fuel that's being injected into the engine, you either have to offset that in your air model or your fuel model, and you really don't want to do that. You don't want to bake error into the calculations. So I would say, if any way possible, go with a fuel that has the same stoichiometric air-fuel ratio or whatever you want to describe that as. Make sure that you're dealing with a consistent stoic. Don't blend fuels. If you're going to run a fuel like VPC85 or C16 or MS109, let us know that you're going to run that so that we can make the appropriate changes in the stoic point in the tune file, and then make all the additional changes everywhere else in the file. And from a safety standpoint on fuel injector, you can't mix ethanol in on a stock 47-pound injector if you're talking about a phase 2 car. You could probably do it at lower ethanol contents if whoever's tuning the car knows the stoic point or is willing to fudge everything to get it to where it needs to be. But from a safety standpoint, with the amount of power your car is making, you're better off having a 98 pound per hour injector to run an ethanol-based fuel. Or you could stick with the 47, keep the RPM window low, and run a gasoline-based fuel.
Yeah, as
Think
far
that'll-
as the internals to the injector, it doesn't mind so much, but the problems come exactly
From the
there.
tuning side of things.
Yeah, that's all the fuel injector questions.
All right.
Okay.
Well, thank you for joining us today. Next week, I don't think we have any special guests, but next week we'll be on location, won't we?
Yeah, are we Shelby Fest next week?
Yeah, we'll be at Shelby Fest next week.
And from that,
I think so.
from that same, or from a similar standpoint, if these guys have any injector-related questions specifically about your guys' injectors, where can they reach you guys at to get those
Yeah.
questions answered?
Absolutely. Go out we're on Facebook. You know, you can call us on the phone, send us an email to info@fuelinjectorclinic.com. We're always ready to answer questions and happy to help you. As I said, we're part of the team that makes, you know, your car a fun experience to own and drive.
They help you do race car things. All right, well, I guess with that, do you guys want to call it a day or
Yeah.
an episode?
Call it an episode.
All right.
Yeah.
So don't forget to share, subscribe on YouTube, like us on Facebook, and we'll see you next week.
And if you're interested in having your product showcased or doing an explanation of what you guys sell or do, just hit us up at, where would we want them to go? Would that be sales at VMP Performance?
They
or
can start there.
Yeah.
Yeah.
Yeah, hit us up at sales at VMP Tuning or VMPperformance.com, or hit us up through the support tab on the website, and we'll try and get you in here and on the show.
And from us, thank you very much. We sure appreciate it.
Thank you for coming up.
Coming out here.
No problem, sir.
Been a pleasure and nice working with you.
Yeah.
Great.